We are still solving equations with variables on both sides of the equation, but today we're going to talk about some special cases. So, equations do not always have one solution. We're so used to x equals -7, yay! But the truth is, the solution could also be all real numbers. That means any value of x or whatever the variable is could work if you get a number that is equal to itself. For example, when you simplify it down, you get 5 equals 5. That means the answer is actually all real numbers. You can also have the solution is no solution. It does not work. There is not an answer to it if you simplify both sides of the equation and you get an untrue statement such as 7 equals 4. Okay? So we're going to try out these 3 examples and see if any of those other options happen besides getting one solution. We might instead get no solution, or all real numbers is the solution. So we're going to start here. We are going to build our fence. We are going to distribute 4 times x is 4x. 4 times 5 is 20. So I end up with 4x minus 20 equals 4x minus 20. Once you get good at this, you will be able to figure it out at this point, but let's get the x's to one side of the equation. So I'm going to subtract 4x's from this side and 4x's from that side. And what happens is these both equal 0. So what am I left with? -20 equals -20. What this means is any number I plug in for x, this will be true. Well, why is that? Well, because 4x minus 5 is the same as 4x minus 20. So because I came up with a number that equals itself, the answer is all real numbers. Number 2, we are going to start with building a fence. We are going to get all of the x's on one side of the equation. Again, I run into a situation where I have 3x and 3x. So which side has less? They have equal. So I'm going to subtract 3x from both sides of the equation, and that will make a 0 here and a 0 here. So I'm left with -9 equals 10. Is it true that -9 equals 10? No, there is no way of these being true. When you take away that from both sides, you basically have the same number, but this is saying subtract 9, this is saying add 10, and you're trying to make them equal. It's not possible. So the answer is no solution. This one, looks challenging. So let's challenge ourselves. Let's see what we do. All right, I'm going to start with building my fence. It looks like I have a distribute. So I'm going to do 2/5 times 10x and 2/5 times 15. In case I'm feeling a little insecure about multiplying that in my head, I can always write it out. The 2/5 times each of those parts. I'm going to write that 10 over 1. The 15 is 15 over 1. On the right side of the equation, what do I do first? Can I subtract before I distribute? No, I need to distribute first, right? That's our first step of simplify. So what am I distributing? A -4. What's that? A -4, you're right! Awesome. So I'm going to keep my 18, and what is -4 times x? -4x. What's -4 times -3? +12. You could say, or minus a -12, but what is that? That's actually the opposite of a negative, which is a +12. Excellent, let's keep simplifying. I see this simplifies. 5 goes into 5 once, 5 goes into 10 twice. I end up with 4x plus 5 goes into 5 once, 5 goes into 15 3 times, 6 equals, I see something I can simplify here. 18 and 12 are like terms, so I'm going to add those, and I get 30 minus 4x. All right, do I have more x's over here, more x's here? Here, because I have positive, so let's get rid of these. So I'm going to add 4x and add 4x. When I do so, that makes 0. And here I have 8x plus 6 equals 30. Do you think it's going to be all real numbers or no solution? No, at this point I have x's on this side, so it looks like I'm going to come up with one solution. Let's see what that solution is. Subtract 6 from both sides. I get 8x equals 24. Divide by 8, divide by 8, and x equals 3. Excellent. All right, here's your problem that I'd like you to try next. Number 4. All right, give this one a whirl. We'll talk about it in class tomorrow. Don't forget to build your fence first. Looks like you're going to have to distribute here and distribute here, combine like terms, simplify as much as possible, and then get all the variables on one side of the equation. All right, pause and write it down. Bye! And we are about to go into a forest where we'll probably get swarmed by bugs just like Pigpen.